Let's continue our program now and recognize our award and other scholarship winners. The Olin E. Teague Memorial Scholarship of $4,000 is awarded to an outstanding graduating high school student who intends to pursue higher education in science and technology. This year's recipient is Kathryn Van Artsdalen. A senior at Walter Johnson High School in Bethesda, Maryland, Kathryn is being recognized for the modeling of how the magnetosphere responds to solar wind input and pre-existing conditions, allowing scientists to accurately predict future magnetospheric responses. Ladies and gentlemen, Kathryn Van Artsdalen. Our next award goes to the winner of the 2015 Dr. Robert H. Goddard Memorial Scholarship. This $10,000 award is given to an outstanding student who plans to pursue undergraduate or postgraduate studies in science and engineering. This year's recipient of the Goddard Memorial Scholarship is Michael Staab. Michael is a student at Wichita State University, and he was selected for his continued education with an emphasis on aerospace systems design to include the design of future interplanetary spacecraft. Ladies and gentlemen, Michael Staab. Our next group of award winners were nominated and selected by peers and leaders in their respective fields. Honoring the first director of the National Reconnaissance Office, the Dr. Joseph V. Charyk Award recognizes individuals who have made outstanding contributions to the National Intelligence Space Program, and in particular to the mission of the National Reconnaissance Office. This year's award goes to Mary Johnson, the Space Systems Program Manager, responsible for leading a congressionally directed, over $450 million firm fixed price acquisition program, delivering a cost-effective, operationally responsive asset to U.S. and allied intelligence users worldwide. Ladies and gentlemen, Mary Johnson. The NOAA David Johnson Award recognizes the achievements of young professionals who have shown outstanding innovation in the use of satellite data for operational environmental application. Before I present this award, please join me in a moment of silence as we honor the memory of Gary Davis, a lifelong NOAA servant who first conceived of this award and who we lost last year after his courageous battle with cancer. Ladies and gentlemen, a moment of silence. Thank you. The 2015 NOAA David Johnson Award goes to Dr. Michael Pavolonis, a physical scientist at NOAA for developing cutting-edge methods to convert satellite data into actionable information for mitigating hazards caused by volcanic eruption and severe convection. These techniques improve the accuracy of volcanic ash cloud advisories and severe weather warnings. Ladies and gentlemen, Dr. Michael Pavolonis. The Space Club Educator Award was established to recognize the importance of teachers in motivating and guiding students. We present this award to Dr. Shelley Canright, Senior Advisor for Education Integration, NASA Headquarters, Office of Education. Shelley is being honored for her career as an award-winning space science educator, manager, administrator, and innovator. Her pioneering efforts in distance learning, gaming, NASA Connect, and other programs have garnered national recognition and 2 Emmy Awards. Ladies and gentlemen, Dr. Shelley Canright. The Astronautics Engineer Award is presented annually in recognition of an aerospace engineer who has made outstanding contributions to the National Space Program in the field of engineering or engineering management. Tonight, we honor Christopher Singer from the Engineering Directorate at the NASA George Marshall Space Flight Center. Christopher is recognized for his 32 years of engineering leadership, serving as NASA Marshall's primary technical authority on programs such as the Space Launch System, the Dream Chaser spacecraft, Mighty Eagle lander, and the Orion program, just to name a few. Ladies and gentlemen, Christopher Singer. The Nelson P. Jackson Aerospace Award is presented to a government industry team that worked together during the preceding year to make an outstanding contribution to the missile, aircraft, or space field. Please join me in congratulating the NASA Lunar Laser Communications Demonstration Team, represented here tonight by Dr. Donald Cornwell, NASA Mission Manager, and Dr. Don Borison, MIT Lincoln Laboratories Principal Investigator. The team they represent is being recognized for record-breaking achievement using broadband lasers for space communications. The team achieved rates over 6 times higher than previous missions and is comprised of members from the NASA Goddard Space Flight Center and the Massachusetts Institute of Technology's Lincoln Laboratory. Ladies and gentlemen, Dr. Donald Cornwell and Dr. Don Borison. The General Bernard Schriever Award honors the father of Air Force space and missile programs. The award highlights excellence in military space operations and acquisition. Tonight we recognize Colonel William Hodgkiss, United States Air Force, Director of Launch Systems Directorate, Space and Missile Systems Center, Los Angeles Air Force Base. Colonel Hodgkiss led the Defense Department's 4th largest program with a direct impact on warfighter support and national security. He flawlessly managed all aspects of the Evolved Expendable Launch Vehicle program and is the lead architect for the nation's next space launch service provider, assuring access to space through the year 2030. Ladies and gentlemen, Colonel William Hodgkiss. The National Space Club's Press Award recognizes sustained, decades-long excellence in journalism that has both supported and underscored the importance of our nation's space endeavors. This year we acknowledge Associated Press journalist Marcia Dunn. For nearly 50 years, Ms. Dunn has extensively covered the human side of space exploration. In total, she covered and witnessed 99 space shuttle flights through the final mission in 2011. More recently, she has focused on astronomy and robotic missions and was selected as a Knight Science Journalism Fellow at the Massachusetts Institute of Technology. Unfortunately, she was not able to join us this evening, but please join me in a round of applause for Marcia Dunn. I am now pleased to present the highest honor given this evening. The Dr. Robert H. Goddard Memorial Trophy is awarded in recognition of significant contribution to U.S. leadership in the field of rocketry and aeronautics. The winner of this prestigious award is selected by a distinguished panel of leaders from across our space community. On March 16, 1926, this award's namesake, Dr. Goddard, successfully launched the first liquid-fueled rocket in Auburn, Massachusetts. 4 days after that launch, tonight's Goddard Trophy winner was born. The recipient of the Goddard Memorial Trophy is Dr. Harold Rosen. Dr. Rosen is a founder of the modern communications satellite industry and is widely known for his leading role in the development of SYNCOM, the world's first geostationary communications satellite. He led the team that developed a prototype geostationary satellite from inside a division of the Hughes Aircraft Company, now a part of Boeing Network and Space Systems. His accomplishments led to the present success of the commercial satellite industry, which now connects our global community with worldwide broadband communications. And if that weren't enough, during the dinner, Norm Baker came up to me and informed me that When Norm was Space Club president, he presented the Astronautics Engineer Award to the same Harold Rosen at the awards dinner in 1964. I was unable to attend that dinner, given that I hadn't been born yet, but I would have been there otherwise. Ladies and gentlemen, I am honored to present the 2015 Goddard Memorial Trophy to Dr. Harold Rosen.
Thank you, Gary, for those kind words, and thanks to the National Space Club for this great honor. I first became aware of the value of rockets in exploring in a lecture about telemetering from rockets, the measurement of cosmic rays at very high altitudes, given by Professor Bill Pickering at Caltech, who later became my mentor and PhD thesis advisor, and then director of JPL. In fact, he was, I think, the longest serving director of JPL. This was in 1948, a full 10 years before the first Goddard Memorial Dinner. Soon after, while still a graduate student, I began working for Raytheon at the Naval Air Station at Point Mugu, California, on rocket-propelled, radar-guided anti-aircraft missiles. It was a very exciting time, and the experience I gained in guidance and control optimization, lightweight electronics, was particularly valuable in what was to come next. For in 1957, as I was engaged in advanced airborne radar development at Hughes Aircraft Company, our department's most important program was suddenly canceled. And my boss challenged me to find a worthwhile new project that would keep our skillful staff gainfully employed. Since Sputnik had just propelled us into the space age, I naturally wanted it to be a space program. And since the world's communications was in such a sad state at that time, international telephony was very expensive and very hard to schedule. And transoceanic television was impossible. But it was known that a suitable satellite system could alleviate those problems. But what kind of satellite program? At that time, the Bell Labs, which was the world's preeminent R&D and communications, the preeminent company in the world, they were saying pretty loudly that geostationary satellites were impractical. They said that because they felt that they would be too heavy to be launched by the small rockets that were then available. And even if they could be launched, they would be so complicated that they'd never get the lifetime that would be necessary for a commercial operation. But Bell Labs had been involved in developing equipment for ground stations, and they had no particular incentive for making things light. Furthermore, I felt I had a little more experience in control systems than their chief scientists. So one day I had an epiphany while I was thinking about these matters. I thought that if we used spin-phased impulses on a spin-stabilized satellite, we could greatly simplify the control system for a geostationary satellite, and in simplifying it, get rid of one of the lifetime problems associated with it. And then combining that with our lightweight experience, our lightweight electronics experience, I thought we could really make a practical system. So I gathered a small team of my colleagues, each very talented in his own field, and we worked on a proposal, and we quickly came up with one. And I thought, boy, that was the end of it. We've got it made now. But that was just the beginning of a long struggle. because it wasn't easy to get any kind of venture capital in those days. I have a younger brother who later became a very famous venture capitalist, but unfortunately he hadn't gotten into the business at that time. And anyway, eventually, after much struggle, we finally got the necessary backing, and were able to get the program called SYNCOM, for synchronous communication, started. And that was followed by, eventually, the communication satellite industry. And most recently, just 12 days ago, I was thrilled to watch on the internet the countdown and launch of 2 Boeing satellites, 2 brand new satellites, both of which have all electric propulsion. There's no chemical propulsion at all, just the ion engines. And they're very successfully on their way. In about August, they'll reach their station, and it'll be another milestone for Boeing. I'm presently designing a satellite-based gravitational wave observatory, which will give us a new window on the universe. I'm also starting to investigate a robotically constructed long wavelength radio observatory on the backside of the moon. And I'm doing this in conjunction with JPL scientists, Caltech astronomy professors, and my colleagues at Boeing. And it would be wonderful if in the future we could recruit the talented Sophia Laporta to help us explore the universe. Thank you.
Thank you, Harold. Nicely done. Nicely done. Thank you, Dr. Rosen. You honor us with your presence here tonight.